use the whiteboard today because I'm not going to pull in any PowerPoints. So, binomial distribution. Write that down, binomial distribution. Now, I don't know what you've seen in high school, but I know usually in this unit, I start going through stuff that you haven't seen before. Okay, so you might want to, I don't know, Math 120 at Seneca High School is different from Math 120 at Westside, and Math 120 at Westside is different than Math 120 at, or whatever y'all call it. What do y'all call it? Probability and statistics is different from Crescent, and Crescent's different from Hannah, and blah 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 blah. So I don't know what you've had as far as binomial distribution. Binomial distribution is when you have a table of probability, and we're just going to do it this way. I'm just going to show you an example. But before I show you an example, there's two tests of binomial distribution or probability distribution. I call it probability distribution. Sometimes you'll hear me call it binomial distribution, but probability distribution. Okay, probability distribution, the two tests are that the summation of all the probabilities are equal to 1. Okay? So when you have a table and you have all these probabilities on the right-hand side, you need to add them up to see if they equal what? 1. If they equal 1.05, then it's not a probability distribution. If you get 0.95, it's not a probability distribution. Now, there are some books that will take 0.9999 to 1.001 or something like that. This is where you need to check into your book. I think this book is pretty much a 1. But you need to look in your book and look in this section. I don't know what section we're in. Somebody look on your outline and tell me what sections we're in. I think we covered like 2 or 3 sections in 6 and 2 or 3 sections in 7. So this would probably be 6.1 and 6.2. Is that right? Yes. Now, area under a curve is when we get into non-calculus area under the curve. Is where we get into 7.1 and 7.2. Now, that is technically the easiest math that you're going to be doing. All right? But some of y'all are going to screw it up. Okay, some of y'all are going to make it difficult. That's what students usually do. They make it difficult, the 5 or 10% that break the handle with the banana. That's where they do it. Another thing, each probability, and y'all know this, has to be between 0 and 1. 0 and 1. Okay, so each probability must be between 0 and 1. So if you have a negative 0.006, you know that it's not a probability distribution because you can have a negative. If you have a probability of 1.05, you know that's not a probability distribution. So if you have this on the test, make sure you make those notes. Why don't you write this stuff down? That's a cue to get your stuff out. Did you write the book? Okay, then get your stuff out. I'm sorry, I'm not picking on you. Since I had that dead head up here in front, I'm not doing that no more. Because the dead head up in the front, he didn't write anything down, he didn't bring a notebook, he didn't bring a pencil, and then he ended up biting me in the rear end by saying, oh, I didn't tell him that da-da-da-da-da. Yeah, and then I had to go to my department head and because of that dead head. So I'm not going to have anybody not writing material down. If you don't want to come to class, don't come to class. Got it? All right. Now, let's go to the next one and let's show you a probability distribution. Well, I'll just do it this way. You have 3 couples that are going to have children, or you have one couple. Let's do it this way. One couple that wants to have 3 kids. Let's do that. One couple that wants to have 3 kids. And with recent probability, recent, whatever you want to call it, data, recent data suggests that the probability of a boy is equal to 0.5, well, let's go with 0.4 because it's usually lower, 0.47. Okay? Construct a probability distribution All right, so do that. Now, I'm not going to ask you how many people know how to do it because I probably guess more than half of you probably don't know how to do it. Anybody have any idea? Well, first you got to do your sample space first. 3 kids. Start with boy, boy, boy. End with what? Girl, girl, girl. Boy, or I'm sorry, I do this a certain way, so that's why I tell y'all to write it down and have it on an index card. Girl, boy, 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 girl, boy, 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 girl, and then I go backwards and I go boy, girl, 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 boy, girl, and girl, girl, boy. There should be 8. Count them and see if there's 8. Okay, so that's your first sample space. Then you say, well, what's the probability of 0 boys? Well, that would be event. The event right here is 0 boys. How many are 0 boys? Girl, girl, girl. So you go over here and you put girl, girl, girl. Probability of that event. Okay, what's after 0 boys? 1 boy. So where is 1 boy? Well, 1 boy. Where's 1 boy? Here's 1. Here's 2. And here's what? 3. So we're going to write those down. That would be boy, girl, girl. Girl, boy, girl. And girl, girl, boy. Everybody with me? All right, you do the rest of them. There's only 2 more. What comes after 1 boy? 2 boys. How many of you have done this before? Okay. I'm not talking about the girl, 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 boy, boy, boy. I'm talking about the next couple of steps afterwards, where you have to actually find the probability. I'm going to ask you that question again in a couple of minutes, because I need to know how much exposure you've had to this, because I really don't know if you've had exposure to it. You may have. So how many are 2 boys? 3. Okay. What is it? The top girl, boy, boy?
Are we going by
Boy, girl, boy?
2 boys exactly?
Yeah, I said right here the probability of 0 boys right here. 0 boys, 1 boy, 2 boys, and of course 3 boys.
Okay. I was just asking, like, I didn't know if you would count.
Huh?
I didn't know if, like, we were doing 2 boys exactly or at least 2 boys. When we're charting, I didn't know if you were going to count the 3, like the all boys would be part of the.
Oh yeah, no, you're going with exactly. Exactly. So 3 boys, I'll do that one for you. Boy, boy, boy. Okay, now you got to do the probability. Okay, this is the sample space. This is the examples that will happen. Now from the sample space, you have to calculate the probability. Now a lot of you say, oh, well the probability of the first one is 1 out of 8. No, not in a probability distribution. Because the probability distribution, I've given you something else besides 0.5 probability. I've given you a point what? 0.47, which throws a monkey wrench into the whole problem. Okay? So if you're met with adversity, what should you do? Quit. Quit and blame it on somebody else. No. Instead of 0.5, you're going to use 0.47. Well, we got to have a complement, because if the probability of a boy is 0.47, what's the probability of a girl? Is the myriad. So the probability of not a boy, which in this case, that's a girl, but I'm going to put boy with a line over it. 0.5 what, 3? So what is the probability of 3 girls? 5.3 to the third power. Therefore, the probability of 3 boys is 0.47 to the what? Okay, now you do the middle two. Now there's a difficult way to do it, and there's an easy way to do it. So I'm going to see if you can figure out the easy way. After you stare at it enough, or look at it, and plug and chug, you might start to see the easy way. Anybody see the easy way? Well, I'll write it out. 0.47 times 0.53 times 0.53 plus 0.53 times 0.47 times 0.53 plus 0.53 times 0.53 times 0.47. That's the long way. What's the easy way?
0.47 times 0.53 squared.
Exactly. 3 times what? 0.47 times 0.53 what? Squared. That's the easy way to do it. So I'm going to go over here. I'm going to erase my sample spaces over here. So I'm going to write this as 3, because I'm adding 2 plus 2 plus 2. 3 times 2 is 6. 2 plus 2 plus 2 is 6. So I'm multiplying. 3 times 0.47 times 0.53 what? Squared. Now somebody do that for me, please.
0.3961.
I'm sorry, what?
0.3961.
Okay, 0.3961. Okay, while we're at it, go ahead and do 0.53 to the third power. Point what?
1489.
1489? Is that what you got?
Yes.
Okay, now let's do this one. 0.53 times 0.47 times 0.47 plus 0.47 times 0.53 times 0.47. And I'm just going to put 3 dots because y'all know what I'm talking about. Okay? So what does this come up to be? The opposite. 3 times 0.53 times 0.47 to the what? second power, and somebody give me that.
0.35.
I'm sorry.
0.35.
It's 0.35 even?
No, 3.5.
Okay, I heard 3.5. 3.512. And somebody do 0.47 to the third power.
0.1038.
0.1038. Now add all those up. All the ones in rectangles, add those up. See what you get. What?
I have a question.
Yes.
Depending on the calculator, do you put the square side in parentheses or outside of it?
It doesn't matter when you're dealing with positives. What you get when you add them all up? That's what you're supposed to do. Now, what is this? Well, let's take all of this. Let's take all of this and one day I'm going to get training on this. Let's go over here in blue. Event, probability of the event. 0 boys, 1 boy, 2 boys, 3 boys. Probability 0.1489. 0.3961. 0.35 12. 0.1038. And this is a probability distribution. You just constructed a probability distribution. Now, how many of you have done that before? Couple? It's not something you do every day. Okay, so make sure you write this down, make sure you tag it, because if you have a homework question that asks you to do to construct a probability distribution, there it is. I don't test you too much on that. If I give you one question, that'll be it on the test. But now, what do you do with a probability distribution? Well, let me ask you this. If I say, what is the probability of having 1 boy? That's the test question. All right, you say 0.3961. But what if I said, as you said a while ago, at least 3 or at least 1? Well, at least 1 would be what? This one, and this one, and you would what? Add them all up. So that's how you read a probability distribution. So if I asked you for the probability of 1 boy, now there's going to be a question on the test or on the homework about people on a jury. This is the same type question. Okay, the probability of at least 1 person on the jury, probability of at least 1, boom, 0.3961. The probability of at least 1 boy is going to be, well, somebody add it up. Well, I'm not going to add all those up. I'm just going to take the complement. What's 1 minus 15 cents? 85 cents. So it's 0.85 or 8, let's see, 0.8511. 0.8511. And that's how you read a probability distribution. Capiche? All right, that's the first thing you need to be able to do in this unit. You need to be able to construct a probability distribution, and you need to know how to read a probability distribution. What else should you know? Well, in the next section, I think, we're going to be talking a lot about N, P, and X. Okay? And the question will go something like this. Suppose you flipped a coin 50 times, and the probability of heads was equal to 0.47. What is the probability of heads if you flip an additional 10 times? This is the second type question you'll get in this unit, 6.1 and 6.2. All right? Now, what have I always told you about n since the first week of class? N is always your biggest what? So in this case, what's your biggest number? 50. So n is equal to 50. So you got to go down here and you say n is equal to 50. Okay, so that takes that out. P. What do you think P stands for? What has P always stood for in probability and statistics? Probability or percentage? Either one, same thing. Probability. All right, so the probability, somebody tell me what that is. P is equal to 0.47. Okay, now I'm not no rocket scientist, but if I've got these two numbers taken out, then what do you think X is? It's a miracle. Now, why am I showing you this problem? Because these problems are very, very simple. You find N, you find P, and you find X. And then you type it in your calculator. I'll show you that later, okay? You've got to type it in that form, NPX. Again, could they ask you? Yes. There's a question they ask you about airplanes and households. Surveying households, or the number of households that watch this TV show, blah, blah, blah. Again, it's very important that you draw a number line and you say, okay, if I got 6 households, 0, 1, 2, 3, 4, 5, 6. Okay, if I got 6 households, and if I say at least 3, what does at least 3 mean? 3, 4, 5, 6. But what if I say at least 1? At least 1 means 1 and 1. And through 6. So what is the complement of at least 1? Probability of 0. See what I'm saying? So you got to know how to do that. So if I asked you 100 homes were surveyed that watch a TV show, The Bachelor, okay? 100 homes, households surveyed, and they watch The Bachelor. The probability of watching The Bachelor is 0.52. Okay? What if I surveyed 20 more homes? What would the probability be? Okay? What if I just surveyed, what's the probability that at least 2 are watching? So you would take NP0 plus NP1 plus NP2. So you've got to know what, and this is just a second type problem. Okay? Then there's another type NPX problem, and this is the third type problem in 6.1 and 6.2. I'm showing you these problems because they're not that difficult, and you go in, and this one you don't even have to use a calculator. The next one I'm showing. Okay? The next one is mean is equal to NP, NP, and the standard deviation is equal to the square root of NPQ. Now your book, I don't know if your book, the 103 book is a terrible book. I think it shows, it won't write Q as it's supposed to. What is Q? The complement of what? P. Q is the complement of P. Write that down. Now, in some books, the 103 book, which is a stupid book, it thinks that you're not smart enough to know what the complement is, so it writes Q as 1 minus P. Okay? The actual, so if I give you, there's 250 people surveyed, the probability that they are watching The Bachelor is 0.2. Then what is Q? 0.8. And then you do that. So those are the only 2 formulas you need to know. And I'm sorry, you really don't need to use calculator for those, unless you're just calculator dependent. Because they usually going to give you easy numbers. They're not going to give you a bunch of decimals. All right, so you got 3 type problems. You got 1, construct a probability distribution. Not only construct it, but be able to what? Read it. Okay? 2, N, P, and X. And I think it's under second bars. We'll get to that in just a minute. And then the third is mean is equal to NP, and the standard deviation is equal to NPQ square root or raised to the 0.5 power. However you want to do it. That's 6.1 and 6.2, which makes up about 20% of your Unit 3 test. And what do you think 80% of your test is going to come from? The next unit. Also, pull out your outline right now. I need you to make a change. Make a change to this unit. This unit is only going to consist of 6.1, 6.2. I mean 6.1, 6.2, 7.1, and 7.2. Chapter 8, I'm going to move into Unit 4. Yeah, move 8.1 and 8.2. Put a circle around it and say Unit 4. Because I like to teach Chapter 8 in Unit 4. So, golly, there's only 4 sections on this test. Everybody should ace this test, this next test coming up. But what is 7.1 and 7.2? 7.2 is the area under a curve. Well, area under distribution. And remember, I told you this is kind of like a preview of what we're going into. I'm going to start covering this Thursday. We're going to start actually going into it. A lot of you already know how to do some of this stuff, so I'm giving you kind of an exposure to it, so you can go ahead and start working on your homework and send the questions in. And hopefully what will happen is somebody will send in questions on this work, and I'll be killing 2 birds with what? 1 stone. I'll be going over homework questions for those that know, and I'll be covering the material for those that what? Don't know. So that's what I'm trying to do here. Okay? I know it's a little bit of common sense, and I know you're not used to that, but as far as the teacher goes, I'm trying to kill 2 birds with 1 stone. But there's 2 forms of distribution. There is uniform distribution. And there is what? Normal distribution. Sorry. Okay. Okay, this is 7.1 and 7.2. 7.1, well, I'll get to that. We'll go to the next page. I'll show you what the difference is. How many of you have studied area under the curve? All right, what do they include? You got to have a Z what? Z-score. Z-score. Okay. Now, I don't use the table as much as I used to because everybody can use your what? Calculator. And it's a whole lot easier and a whole lot less tedious. And since the You know, the syllabus says that you need a TI-83. Everybody should have one. If you don't, you need to beg, borrow, steal. Uniform distribution only deals with one thing. The only thing that we cannot control, and that's what? If we could control it, it wouldn't be uniform. Okay? The only thing we cannot control is time. Even though some people try. Okay? You ever been to a dance recital or a cheerleading competition? You know what I'm talking about. We already had this discussion. And this is pretty sad. All right, so what do? Well, the area under the curve is equal to what? 1. So put you a big, I put 1.0000 and 1.0000. A lot of people say, well, Hubert, why do you write 4 digits? 2 reasons. One is so you won't think that that 1 is just a mark on the graph. Okay? The second reason, the most important reason, is when you're dealing with area under the curve, 4 digits or 4 decimal points means area. Write that down. 4 decimal points means area. If 4 decimal points equals area, what does 2 decimal points equal? Golly, I'm impressed. Then 2 decimal points equals what? You say it out loud. You said it.
Z-score.
Z-score, good. Okay, and that's very important. So from now on, when I write 4 decimal places, you automatically know it's a what? It's an area. If I write 2 decimal places, you know it's a what? A Z-score. All right, let's move into this area because I want to show you the 3 types of questions you're going to see in Chapter 7. You got 3 types of questions in 6, and I'm going to show you the 3 types that are in 7. One, of course, is time. You got a class that lasts 50 minutes. What is the probability of the class going over 55 minutes? Oh, I'm sorry, not 55 minutes, 45 minutes. Okay, what is the probability of going over 45 minutes? Okay, well, the first thing you do is you got to find the height of the box. Because you know the width is what? 50. So width is equal to 50. Let's put width is equal to 50. And the area of a rectangle is what? Length times what? Width or base times what? Okay, you can say width is equal to 50, or you can say base is equal to 50. I don't care which one you say. So therefore, if we have the width and we know the area is what? 1, then we can figure what the height is, right? Now write this down. I'm serious. You're going to be mad on the test when this simple math you forget. So 1 is equal to 50 times what? The height. So the height is equal to what? 1 over 50, Hubert. Thank you. So now I'm going to take my red marker and I'm going to draw a line right there, and we want to know this area right here, that's at what? 45 minutes. So now what are you going to do? Well, what's the width of this? What's the width of this box? Multiply it times the what? So you have your new area. Area at 45 minutes. Area and probability is the same thing. Write that down. Area and probability, percentage, all that's the same. Area at 45 minutes is equal to base times the height. That's going to equal 5 minutes times 1/50th, which is equal to 5 over 50, which is equal to 0.1000. So there is a 10% chance or a 0.10 probability that that teacher is going to go over what? 45 minutes. That's one type problem. I think you'll have 2 on the test. Maybe even 3. Why do I give those problems? Why do I give so many of these? Because you would actually have to break an amble with a banana to miss it. Because I think on 2 of the problems, they actually give you the height. You don't even have to figure the height. So if you mess up this problem, you don't what? Tell anybody. Oh yeah, I got that problem right. Just lie. Because if you tell somebody that you missed this problem, you're hanging a sign around your neck that says I'm a DA. Because it's not that difficult. Capiche? Y'all don't understand or you do understand? Yes. Okay, thank you. All right, the second type problem you're going to see in 7.1 or 7.2 is the curve. Now, I'm not going to get into this one too much because we got plenty of time to get into it. But I'm going to show you, for those of you that know it or have had it before, maybe it'll knock some cobwebs loose so you can actually start to work on problems that's in the questions. 0, 1, 2, -1, -2. The second type question you're going to see is when the mean is equal to 0 and the standard deviation is equal to what?
1.
1. Good job. Okay? Which basically sets up your z-score chart back when we learned it back in Unit 1, I think. Okay? And they say they're either going to give you a z-score and you find the area, or they're going to give you the area and you what? Find the z-score. That's the 2 questions that they're going to ask you in this section. So let's say I give you area or the 40th percentile. That's one question. That's how it's written. It's a little subscript 40. I don't know how many of you know that. I'm trying to feel y'all out. Y'all let me know Thursday how much y'all remember about this, okay? And y'all send me a question. Is that my phone? My phone is on black. Somebody else's phone. Okay, so what do? First, everything you do in this section, you draw a picture. Why? Because you need common sense to tell you if you're right or not. So 40%. Remember our fuel gauge? Remember the fuel gauge? We know this is empty. We know this is a quarter of a tank. We know this is half a tank. We know this is 3/4 of a tank. And we know this is full. So we know that 50% is where? Right there. So I'm going to take my blue marker and 40% would be right in here. Now, one thing about the table always gives you the area to the what of the mark? To the left. You need to write that down if you're going to use the table. The table only gives you the area to the left. So the right-hand side is equal to 1 minus the left-hand side. And I'm going to write that down for anybody wanting to use the table. The right-hand side area is equal to 1 minus the left-hand side. Because the table only gives the left-hand side. Okay, so that's for table people that are going to use the table. But, somebody tell me, we've already figured the area is about right in there. So what is the z-score going to be on this problem without a shadow of a doubt? I'm not asking for a number. Just say, what is it going to be? Not a number, but it's going to be what? Negative. Thank you. It's going to be negative. Why? It's left of 0. So now you pull out your handy-dandy calculator. I'm going to go ahead and give you this one. And you go to second. I think somebody check me. Second, bars, and go to inverse norm. Is it in there? Is it? What number is it so I can, huh?
3.
Number 3. And then you type in 0.4000 because that's that area right here. And it should crank out a negative z-score,
-2533.
0.25. Why did I round to 2? Because it's a what? It's a z-score. That's how you find the z-score when you're given a what? An area. Some of you should be going, oh yeah, I remember this. Okay, if you're not, then don't worry. Thursday, hopefully somebody will send questions and we'll go over some more detail. All right, let's go to the other one. Now y'all have to remind me which one's the other one, because I always get it mixed up between normal PDF and normal CDF. I think it's normal CDF. Somebody check me to make sure. We'll do 1, because what is the area at z is equal to 1.00? Okay, so now we're going to hit second. Somebody tell me what the percentage is. Well, we know this is 50. What's 50 plus 34?
84.
Okay, so I'm going to say it's around 84. Approximately 84%. Okay, that's by the empirical rule. Okay, so somebody type in second, and I think it's, somebody check me, normal CDF, second bars. What number is normal CDF?
2.
I'm sorry, what?
2.
2, number 2. And then we're going to type in negative infinity, negative 9999, to 1. And what do you get?
0.8413.
That's it. So it's normal CDF. 0.84 what?
13.
Now that's the second type question you're going to get. 1, you're going to be asked to do uniform distribution. 2, you're going to be asked to find the area or the z-score given that the mean is 0 and the standard deviation is what? 1. Now just in case, I saw people outside. Okay, we got a few more minutes. I want to go over the third question. Okay, so here is the second type question, and this is the 2 questions I'd ask. I'd either ask for the area, find the z-score, okay, which is a piece of 40, sorry, or given the z-score, find the what? Find the area. And that's the 2 type questions so far in chapter 7. And the third type question is a continuation of this. The third type question, same normal, same empirical rule, same everything, except now the mean is equal to what? Let's say 100, and the standard deviation is equal to what? I'm sorry, it's about 125. That would be some messed up data. 25. Now there's 2 things you need to do now. You need to draw a picture, and you need to fill in the z-score also. Okay, so when I say draw a picture, this is 100, so this would be what? 125. What would this be? 150. This would be 75, and this would be what? 50. And this is 0, 1, 2, -1, and -2. Everybody with me? So now, in the second part of chapter 7, your mean and your standard deviation is totally different. And now the question is going to ask you one of 2 things. It's going to ask you for the area, or it's going to ask you for x. What about the z-score? Well, the z-score is not going to help you here because we're not dealing with z is equal to 1, or we're not dealing with mu is equal to 1 0, standard deviation is equal to 1. Now we got numbers that are actually IQ scores or whatever scores. So now you have to remember this. Z is equal to X minus what? X bar over standard deviation, or X is equal to Oz plus mu. That's the two formulas that you have to memorize for the second part of chapter 7, or third part of chapter 7. Now the reason I don't use, and I told you this before, the reason I don't use X is equal to, I'm thinking here, SZ plus X bar is because that's hard to remember. Okay? SZ plus X bar, that's hard to remember. It's easier to remember Oz plus mu. So that's why I use Oz plus mu. Anyway, what do? Well, let's say that you want to find the test score. Here's the first type problem. You test score at 0.3500. Well, what did I just give you? Did I give you a z-score, or did I give you an area? So you draw a picture. 0.35. And let's say this is 50. So 0.35. We know this is 2.5, and this is 13.5, right? Which is 16, right? That's 16. Half of 34 is 17. 16 plus 13, that's close to, that's what, 29% or something like that? Is everybody following me what I'm doing? Because I don't want you to go, well, where'd you get that number? The empirical rule. This is 34, right? Half of 34 is 17. What's 17 plus 16? 33. I'm wanting 35. So I'm thinking probably my z-score is going to be what? Negative 0.4, maybe? That's approximate. And what's between 75 and 100? I'm asking y'all.
87.
87, so I'm going to say around 80. Okay? How did I do those two numbers? Strictly by the empirical rule. And you have to understand what I just did there to understand you're approximating. Why you're approximating? So when that calculator spits out an answer, you don't write it down like an idiot and it's the wrong answer. Okay? Let me give you an example. You ever been to a store or restaurant and you give somebody money and they give you totally botched up change? You know what I'm talking about? Because they don't know how to spell mom backwards. Well, that's what you're doing here. You're doing the common sense empirical rule to get some kind of an estimate. So when your calculator spits out an answer, you don't write it down even if it's the wrong answer. I hope you understand what I'm talking about. All right, so what do? Well, first you got to have a z-score. Somebody take your calculator and type in inverse norm 0.3500. What do you get?
Negative 0.38.
I got negative 0.4. I'm on a good tendency to get this right. What'd you say? Negative what?
0.39.
0.39. Now take that, plug it in here. X is equal to, what's our standard deviation? 25 times negative 0.39 plus what? Somebody crank that out for me. Do I know where it's going to be? I think it'll be around 80. If you come up with 127, then you know the answer your calculator is doing is what? Wrong, because you did it by the empirical rule. So what did you come out with?
90.4.
90.4 is close enough. Everybody got 90.4? So, what does that mean if you score 96? That means you're in the top what? 35th percentile. If you scored a 70 on this test, that means you're in the lower what? 35%. Capiche? Those are the 6 type problems that you're going to see on this next test. First 3 in chapter 6, the last 3 in chapter 7. Now, let me just get a show of hands. How many of you have seen all of this before? Okay, so I need to get some questions from y'all Thursday. And those that didn't raise your hand, you don't have to do, if you want to try the homework, there's 2 people in here. One that's seen this before, go do the homework, send in questions. Those that have not seen this before, you're going to try to do the homework, you're going to be lost. You wait until Thursday when I start going over these questions. You see what I'm saying? 2 people. You decide which one you are, come back Thursday, we go over them, okay? Let me get the roll. I'm going to take the roll today. I'm probably not going to take it Thursday. I don't know. Miss Anthony, you good?